This is Kimberly Karras, and today we're going to do a test 2 wrapper question. This is question number 1. We have to find the potential distance from A to B near the center of a disc, and because of a disc and a rod. So the points are near the center of the disc, so that helps formula-wise. So in order to set up the problem, we have to know what things have an electric field at point A and B, like what things make them the electric field. And those two things in this case are the disc and the rod. So you have to find the sum of what the electric field is from the disc and from the rod. So the formula for the potential difference is the negative integral of E dl. So the electric field of a disc is half that of a capacitor, and we can use the approximation because the distance from this distance d is a lot smaller than the radius of the disc. And then we have to do the electric field of the rod, which we can also use the approximation because in the problem it said that the distance here is a lot less than the rod's length. And in this case, the rod goes into the page or out of the page. So we basically just plug and chug back into here. Remember this negative sign, and that this disc is negatively charged and this rod is positively charged. So once we plug and chug, that's what the formula would look like. And remember, these two negatives cancel out because the disc is negative. To find the parameters, it tells us in the problem that A is d minus h over 2 away from the disc, and we have to take into consideration that the parameters are usually in relation to that object. So the disc, it's these from here to here, but notice how for the rod that they're flipped. It's minus d minus h over 2 and d plus h over 2 in relation to the rod. It's how far away you are from a rod or how far away you are from a disc. So that's how we got these parameters and these ones. Notice there's an extra negative sign because the distance vector would be going in the opposite direction from the rod. Because the distance vector goes this way, and the rod, it goes the other way. It goes like that way. It goes the other way. So there's an extra negative right here on both of the top and bottom bounds. So all we have to do once we get the bounds is to integrate them. So the electric field because of the disc is constant, so we just have to you just left a dx up here, so you just plug and chug back in once you solve the integral. And this one's 1 over x, so the integral, that's natural log of x. And we just plug and chug to get this. Remember that when you have a natural log of something, it's the same thing as dividing. So if you divided these two numbers by each other, you would eventually get this, which is what turns up in the natural log, and that's how you get the answer.